is modeling with variation. Now, remember that, or using variation, I guess I should say, instead of modeling in mathematics means that I'm going to go from a verbal description of something to an algebraic description, you know, like so it's got letters and numbers in it, maybe to a graph, maybe to a table of values, right? We've got 4 different ways that we can model, and that's what it means, just represent information that's given to us. And so what we're going to be doing in this section is talking about how to come up with the equations that go with these types of variation problems, where they give us different information. We have 2 or 3 different kinds of variation. The first objective is talking about direct variation. Now, something forms direct variation if it's linear. In other words, like if one thing increases, the other thing increases, right? And it's got to go through the point 0, 0. So for it to be direct variation, those 2 things have to be true. Linear, so it forms a line, and it's got to go through the point 0, 0. When you talk about this, what you're looking for in a verbal description are the words y varies directly as x. Or it could say y is directly proportional to x. Okay? Anytime you see that, then the equation that you're going to be talking about is y is equal to some number times x. Can't have anything added to it, right? Because if I subtracted or added anything, it would move it away from the 0, 0. Right? The only linear equations that pass through the point 0, 0 are the ones that don't have anything added or subtracted. Okay? Parent function, remember, it goes to 0, 0. If I add or subtract, it would slide it up or down. Okay. And then this k, well, that's just the number times x. That's called our constant of variation, or the constant of proportionality. So k is the constant of variation, or constant of proportionality. Okay. You can call it either one. We did this in Algebra 2. Hopefully you'll remember how to do it. And in the book on page 405, there's a box that gives you the steps for doing this. What they're going to do is they're going to give you a word problem. Check point 1. It's on page 406 if you want to read along. We got the number of gallons of water, and it tells me the letter it wants me to use for that. So I'm going to write that. W is gallons of water. Used when taking a shower varies directly as the time. T is the time. 10 minutes. It's always a good idea to write for yourself what that unit is. Okay, so where it said this, the number of gallons used when taking a shower varies directly. So W is equal to some K times T. Anytime you see that word varies directly, you take the letter is equal to K times the other letter. Okay, there's your equation. The shower lasting 5 minutes. So if I've got a shower that lasts 5 minutes, so 5 is T, uses 30 gallons of water. So 30 is W. Then it wants to know how much water is used in a shower that lasts 11 minutes. Okay, so step one is writing all the information down, reading it and writing it down, looking for your variables, just writing down what the variables stand for, deciding if it's direct variation or inverse variation or any of the other things that we're going to talk about. Then you will always be given one piece of information that tells you both variables. You're going to use this information to find K. So you'll always take the one where it gives you both pieces of information together, and you'll find that constant of variation. So you'll say 30 is equal to some K times 5. I'm just plugging in the 30 and the 5. So K is 6. So if I divide by 5 to solve it, K is 6. Now, once you have K, then you take K to the second step. Your new equation, and sometimes on the test they ask you to just stop here. What is the equation for this? The equation is y is equal to 6 times t. Okay? But in this particular problem, they want us to go a step further, and they want us to find out exactly how many gallons of water have I used. So you'll do 6 times 11, which is 66 gallons. And then you're finished with that problem. The big thing is just remembering that if it says direct variation, you've got to use this equation. Then the next step that people forget is that they've got to use this first piece of information to find K before they can go directly. They want to do it all in one step. It takes 2 distinct steps. If you don't do the first step and find K, you can't use the second step. Okay? Any questions? All right. The next type of variation that we have in here is inverse variation. In inverse variation, what's happening here is that as one thing increases, the other decreases. My favorite one, and it kind of applies today since it started out being 19 degrees this morning, is that the lower the temperature, the higher the coat sales are. As temperature drops, people go buy coats, right? So that's an example of inverse variation. There are lots of different things that show inverse variation. The equation for that is y is equal to k divided by x. And again, the word that you're going to be looking for is that you'll say y varies inversely as x, or y is inversely proportional. And K is still our constant of variation. Same steps apply. You're going to pull your information out, the piece of information where you got both of the parts to it, you're going to use to find K. Then you're going to take K and put it back into the equation and then use that to predict any future values. Everybody got that written down? Everybody got it? All right, checkpoint 3. Checkpoint 3 says the length of a violin string varies inversely as the frequency of its vibrations. So I'm going to let L be the length of the string. And F is going to be the frequency of vibration. And it says here that the length, L, varies inversely, K over F, the frequency. Okay, so I've got my equation. It says inversely, you put the K over the second variable. Then I read it some further here in the next sentence. It says that a violin string that is 8 inches long, so L is 8, vibrates at a frequency of 640 cycles per second, so 640. Then it asks me, what is the frequency of a 10-inch string? So this is the piece that they gave me both parts to, so I'm going to plug that back into the equation. So 8 is equal to K divided by 640. Step number 2 is always to find K. And I've got to multiply both sides by 640. 5120. Thank you so much. So then when I come over here to predict this future value, the equation that I'm actually using is L is equal to 5,120 over F. Okay? So this is the equation. Sometimes they ask you to stop here. All you had to do is find the equation. But in this case, again, they asked me to actually predict a future value with it. It says, what is the frequency if the string is 10? So I'm going to have 10 is equal to 5,120 divided by F. Now, for some reason, this really bothers people when the variable's in the denominator. You have to multiply by F. So you get 10F is equal to 5,120, and then divide by the 10. Yes, do your steps that you've always done. So the frequency is 512. The other thing that you can do is you can flip them both upside down. You could have flipped it, made it F over 5,110, 20, but then you had to make this one over 10, and that's the part people forget to do. So I don't teach them cross multiplied. Yes. But the reason that works is because you're doing this. You're just skipping a step. Yeah. Yeah. Okay? So, direct variation means it's K times X. Inverse variation means it's K divided by X. All right? And I have two other types of variations, and we're through with this section. A combined variation means that it's got direct and inverse variation in it. Lots of our physics problems use combined variation. Boyle's law. That's back from chemistry. Okay? When it talks about the pressures of gases. Yes. Alrighty then. But it works the same way as before. They'll give you all the information. You'll be looking for the words varies directly for the direct variation and varies inversely for the inverse variation. Look at checkpoint 4. It says the number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems and inversely as the number of people working to solve the problem. So I've got how many variables? 3, right? I've got, and it doesn't really tell me what I need. I'm going to let n be equal to the number of minutes. Is that all right? Or do you want it to be m? N is number of minutes. And we need a variable for the number of problems. You'll call that p. And I need a variable for the number of people. So, what do you want? I only want to use one letter. Q. Too late. Number of people working on the problem. Okay. Okay. So now I go back into the problem and I read it. It says the number of minutes needed varies directly. So number of minutes, there's my equal sign. Varies directly as the number of problems. So K times P goes in the numerator, right, if it varies directly. And inversely as the number of people. Inversely goes in the bottom. And I don't need another K. 1K per problem is plenty. Okay? I do, just to keep me, that way I don't think I've used that for a variable. You know what I'm saying? You can call it, some books use C, some books use other letters. In this book they use K, and we just consistently, I go ahead and use K. Yeah, got to have a constant of variation in there. All right, so then go to the next sentence. It says it takes 4 people. So Q is 4. 32 minutes, so N is 32, to solve 16 problems. So P is 16. They will give you that sentence that's got every variable there. Now what do we use that for? To find K. So I just plug that in to find K. So, whoops. Good. Well, can I go ahead and just reduce here, please? Make that 32 is equal to 4K. Then I can divide by 4. So K is 8. So my equation that I'm actually working with is N is equal to 8 times P divided by Q. I divided 4 into 16 and got 4, so I had 4K, and I divided both sides by another 4. Now I divided it out. All right, so we good? Now we got that last sentence that says, how many minutes will it take 8 people to solve 24 problems? So how many minutes? I'm going to leave the N alone. So 8 problems. I didn't think it was 8 problems. How many problems was it? 24 problems. And how many people? 8 people. And make sure you put the numbers where they belong. That's why you take the time to write down your variables and what they stand for, so that when you start plugging it back in, you got it written down. Okay? So it's going to take us 24 minutes. Okay? So all there is to combined variation. In combined variation, they're going to have some inverse and some direct variation in the same problem. You just put it in the parts of the problem where you need it. Okay? The last problem is about, the last objective is about joint variation. This is it. the last objective in this section. Now, in joint variation, it's just direct variation. It's just going to have more than one of them. Okay? So joint variation is just direct variation. It's just that there's more than just two variables. Okay? So it varies jointly. So checkpoint 5 says the volume V, volume of the cone, varies jointly as its height, so we're going to let H be height. They tell me in this problem what variables to use. And this is square of its radius. R stands for radius. Again, I think that's essential. You need to take the time to write your variables and put what it stands for over to the side. It really will help. Okay? Now let's go back to the sentence again and let's write down what the equation is from that sentence. It says the volume varies jointly. So B equal to K times, remember jointly only means direct variation, its height, H, and the square of its radius, so R squared. So there's my formula. Then it gives me some given information. It says a cone with a radius of 6 feet and a height of 10 feet has a volume of 120 pi cubic feet. So what am I going to use that piece of information for? To find K. Okay, so I've got 120 pi is equal to K times 10 times 6 squared. Let's plug the numbers in. So we've got 120 pi is equal to 6 times 6 is 36, times 10 would be 360. And then what do I do? Divide by 360. So K is equal to pi over 3, because if I reduce that, that's 120 goes into 360 3 times, right? Okay, so pi over 3 is my number. Nope. Okay, now, my formula is that the volume is equal to pi over 3 times the height times the radius squared. That should look pretty familiar to you. You've been seeing it on a tax chart for years and years, right? So, yep. That is the volume for a cone. You just came up with it. Da, 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 da. All right. Now, in checkpoint 5, they do want us to find the volume of a cone having a radius of 12 and a height of 2. So what am I going to do here? Square. Okay, so the volume is equal to pi over 3 times 2 times 12 squared. So I've got 2 times 144, which is 288. So pi over 3 times 288, which would be, what, 96 pi? Somebody do 288 divided by 3. 96 times pi. Okay. That's how you do all these variation problems. You just read the problem. From the problem, it'll tell you what kind of variation, so you know what kind of formula to plug it into. Take the given information to find your K, and then use that to predict any future values. Any questions? The homework for this section is on page 411. You're going to do 1 through 10 all, and then 22 through 38 even.